Hey, I'm Trevor from the Missouri S&T Human Powered Vehicle team, and I'm going to give you a quick overview of our innovation project and what it does. Now, this year we're doing a rider diagnostic system, so it's a bunch of integrated sensors which are going to give you some more data than you would generally get from just a conventional fitness tracker. So attached to the bike we have a heart rate monitor, which is going to give you pulse rate, and we have a Hall sensor, which is going to give you speed from a magnet that's going around the wheel. Now these are going to be read by an Arduino, which is then going to communicate with Raspberry Pi serially, and the Raspberry Pi is going to store all the data locally until you want to pull it off. And that data is going to be time, heart rate, speed, gyroscopic orientation, and temperature. And the cool thing about this is the Raspberry Pi is only going to connect to something external twice, once when you want to turn it on, once when you want to turn it off. So this is already initialized. We can just press this button. You're logging a ride right now, and we can press it again. Congratulations, you've logged your first ride. So now we're actually going to go into the software and see what's happening inside of everything. This is the final app, the real meat of the project, where all the data goes and we actually do something with it. So you can see here that we have a lot of different options and we can plot anything on the X or Y axis. So if you want to do something basic like time versus speed, you choose your plot type, choose your rider. Right now our rider is Fritz, and this is our ride date, and it just initializes the plot just like that. We can see power 2, fairly closely correlated because this is just the bike's output power. Or if we wanted to do something a little bit more complicated, we could do speed versus output power, and that relationship is just determined by the grade, by how much the bike is leaning. Now, if we do time versus heart rate, you can see that it's still a bit shaky just because it's actually vibrating a lot. So once we get our mounting method together, then I expect that to go down a lot. Now we can also handle multiple rides. So if we were to look at distance versus speed, we can see that the rides are a bit different length, and we can also do distance versus, say, lean, and we can see the correlation in lean because this is over the same course, and so the rider is leaning at around the same time. Now you can do 1,000 other combinations, and that's the point of this innovation, is just you can do whatever you want and you can draw whatever conclusions you want. Everything's meant to be easy to use, everything's meant to be editable, and so you can basically see whatever statistics you feel like seeing. This has been the Missouri S&T Innovation Project. Thanks for watching.